Welcome to our presentation on averages and variation. Today, we'll explore the key concepts that help us understand data better. We'll cover measures of location such as mean, median, and mode, as well as measures of variation including variance, standard deviation, and quartiles and boxplots. Measures of location, also known as measures of central tendency, describe where most of the data values tend to cluster. The main measures include mean, median, and mode, each providing unique insights into the data's central point. The mean, or average, is calculated by summing all the values in a dataset and dividing by the number of values. It represents the center of the data. Given 24-hour water absorption percentages for specimens, we can find the sample mean by summing the values and dividing by the number of observations. The mean can be misleading when there are outliers in the data. Even a single outlier can significantly skew the mean, making it unrepresentative of the overall dataset. The mean is simple to calculate and widely used, but it is sensitive to outliers, which can distort the data representation. The median represents the middle value in a dataset when arranged in order. It is useful for datasets with extreme values, providing a more accurate measure of central tendency. To find the median of a dataset, sort the numbers in order and identify the middle value. If the dataset has an odd number of observations, the median is the middle value. For datasets with an even number of observations, the median is the average of the two middle numbers. The median is resistant to outliers and accurately reflects the middle of the data, but it may overlook significant changes in the dataset. The mode is the value that appears most frequently in a dataset. It is the most common observation and does not require any mathematical calculations. In a dataset, the mode is the most frequent response or value. Multiple modes are possible, such as bimodal or multimodal distributions. To find the mode, create a frequency distribution and identify the value with the highest frequency. For example, in a class of 25 students, the mode of their exam scores can be determined. The mode is applicable to both categorical and numerical data. A dataset can have multiple modes, referred to as bimodal or multimodal, or a single mode, referred to as unimodal. The mode is useful for identifying the most common category in datasets, resistant to outliers, and easy to identify, making it a quick and simple measure to compute. The mode is not always unique and offers limited information about the overall data distribution. It can be challenging to identify in continuous data without categorization. Measures of variability quantify the extent to which data points differ from the central value. Key measures include range, standard deviation, and variance, providing insights into the data's spread. The range is a measure of variability that indicates the spread of a dataset. It is calculated as the difference between the maximum and minimum values. To calculate the range, subtract the lowest score from the highest score. For example, in a dataset with values 7, 6, 3, 3, 1, the range is 6. Standard deviation measures the amount of variation or dispersion in a set of data values. It indicates how spread out the scores are around the mean and quantifies the difference of data points from the average. The sample standard deviation and population standard deviation are two measures of spread or dispersion. They are used differently based on whether the dataset represents an entire population or a sample from a population. To calculate the sample standard deviation of the given data set, we first find the mean, then the squared differences from the mean, and finally take the square root of the average of these squared differences. Variance measures how spread out the values in a data set are around the mean. It quantifies the degree of variability or dispersion and is the square of the standard deviation. The website fueleconomy.gov provides information on fuel characteristics of various vehicles. For example, we consider a sample of 11 fuel efficiencies for the 2009 Ford Focus with an automatic transmission. Here is the data for the 11 cars, including their fuel efficiencies, deviations from the mean, and squared deviations. This data helps in calculating the variance and standard deviation. Rounding effects account for the sum of deviations not being exactly zero. The variance is calculated, and the standard deviation is derived, showing a representative deviation from the sample mean. Boxplots, or box and whisker plots, provide a graphical image of data concentration. They show how far extreme values are from most of the data and are constructed from 5 key values. Boxplots summarize central tendency, spread, and skewness. They are useful for comparing distributions, less affected by outliers, and provide a clear representation of data distribution. Boxplots offer a simplified view, potentially missing distribution nuances. They do not show individual data points, are less informative for small datasets, and assume symmetry in data distribution. Consider the test scores of 10 students. To create a boxplot, we first arrange the data from smallest to largest, which helps in identifying the quartiles and constructing the plot. To calculate quartiles, we find the median, first quartile, and third quartile of the sorted data. These values help in understanding the data distribution and constructing the box plot. The interquartile range, IQR, is the difference between the third and first quartiles. The whiskers extend to the smallest and largest values within 1.5 times the IQR below and above the quartiles.